A 3-second SMTP call in an async endpoint froze the entire server. The event loop was held hostage, every other request queued behind it. Let's break down FastAPI background tasks and async endpoints, how it works, and the exact mistake behind that failure. FastAPI background tasks let you defer work like sending emails or writing logs until after your endpoint returns a response. The async await pattern handles concurrent I/O efficiently, but the key decision is whether to use async def or def. Get it right and your server scales, get it wrong and it stalls. Background tasks execute after the HTTP response is sent, the client never waits. Tasks run sequentially in registration order. Regular def tasks run in the thread pool, while async def tasks run on the event loop itself. Here's a typical registration endpoint using background tasks. 2 tasks are registered, sending a welcome email and writing an audit log. Both run after the response is sent. Notice the try except blocks. Exceptions in background tasks are silently swallowed, so you must log them explicitly. The single most important decision: use async def only when calling async libraries like HTTPX or async. For synchronous code like requests or SMTP, use regular def if FastAPI offloads it to a thread pool. If you must mix, wrap sync calls with Asyncio to thread. Here are the correct patterns. Case 1 uses async def with HTTPX. Case 2 uses regular def for CPU-bound hashing. Case 3 mixes async and sync by wrapping file I/O in Asyncio to thread. Case 5 uses Asyncio sleep instead of time sleep. The async version yields control to the event loop. Background tasks are in memory. If your server restarts or crashes, all queued tasks vanish. Use them only for non-critical work like welcome emails or audit logs. For durable tasks, use Celery or ARQ with a Redis broker. For durable work, use a proper queue. Here, background tasks handles disposable logging, while RQ enqueues the email for a separate worker. The API returns immediately, and the email survives server restarts. This is the same issue we highlighted at the start. Here's exactly why that happened. The registration endpoint was declared async def and called SMTP sendmail, a synchronous blocking call. In Asyncio, there's only one event loop thread. A 3-second SMTP handshake blocked that thread, freezing every concurrent request. Health checks timed out, Kubernetes restarted pods, and the server appeared idle. The root cause is calling synchronous SMTP sendmail inside an async def endpoint, which blocks the event loop thread and freezes all concurrent requests. The fix moves the email to a background tasks with a regular def function, so FastAPI offloads it to a thread pool. The fix was straightforward: move email sending to a regular def function registered with background tasks. FastAPI runs it in the thread pool, not the event loop. For async native SMTP, use Async. Also add linting to catch this pattern before it reaches production. This is the #1 production incident in FastAPI. Time sleep inside an async def blocks the entire event loop. Every concurrent request queues behind it. CPU stays low, but the server becomes unresponsive. Never use time sleep. In async code, use await Asyncio sleep instead. If your background function raises an exception, FastAPI silently swallows it. The API returns success, but the email never arrives. Always wrap background task bodies in try except with logging. The thread pool for sync endpoints has a default size of min 32 OS, CPU count +4. On a 4-core machine, that's 8 threads. If all are occupied, the 9th request waits. Monitor active thread count and consider converting high-traffic endpoints to async. This is the hook incident's root cause in code form. The background task has no error handling. If SMTP fails, the exception is silently swallowed. Always wrap background functions in try except with logging. In FastAPI versions prior to 0.95, background tasks used a custom thread pool executor instead of any I/O. The default thread pool size was min 32 OS, CPU count +4, but the pool was not shared with the endpoint thread pool, leading to potential double exhaustion. Upgrade to FastAPI equals 0.95 for unified threadpool management via any I/O. When a background task must call synchronous I/O, e.g., SMTP, sendmail, wrap it with Asyncio, to thread inside an async def task to avoid blocking the event loop. This pattern keeps the event loop free while the sync code runs in a threadpool worker. Add a middleware that records the time between when a request is scheduled and when it actually executes. A delta above 100 ms indicates event loop blockage. This is the only reliable way to detect blocking calls inside async def endpoints, as CPU and memory metrics remain normal. To debug event loop blockage, enable Asyncio debug mode and grep for slow callbacks. Also search your codebase for synchronous I/O calls inside async def functions. These are almost always the culprit. Let's run through some common interview questions. How does FastAPI handle sync versus async endpoints? FastAPI runs def in threadpool, async def on event loop. What happens if you call time.sleep in async def? Blocks entire event loop, freezing all requests. How does BackgroundTasks differ from Celery? BackgroundTasks is in memory, no retries. Celery is durable with a broker. And a few frequently asked questions. Can BackgroundTasks survive a server restart? No, tasks are in memory and lost on restart. Should I use async def for CPU-bound work? No, use regular def to offload to threadpool. How to handle exceptions in BackgroundTasks? Wrap body in try-except with logging and metrics. To recap, match your endpoint signature to your I/O pattern, never block the event loop, and remember that background tasks are not a durable queue. Add linting and monitoring to catch issues early. Ready to go deeper? Up next, FastAPI database integration with SQL Alchemy, then FastAPI file uploads and form data, then FastAPI middleware. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.